All right, how's it going, guys? So for this section of environmental science video, we're going to talk about soils. Soils is essentially the world's largest sponge. So first, we're going to talk about the soil profile. I'll show you a diagram in a minute, but there's a couple of horizons. So each layer of the soil profile, that's how the soil is laid out from top to bottom. If you were to, dig through the soil, and so the top layer is going to be a horizon. This is the top soil. Sometimes there's going to be what we consider the O horizon is organic matter on top of the A horizon, but the A horizon is the top soil. It's the surface layer of the soil. It's approximately 6 inches deep. This isn't the case everywhere. The profile is not, every horizon of the profile is not going to be the same in every single soil, but usually the A horizon is 6 inches deep. It usually contains more organic matter than the other horizons and is typically darker colored because of the organic matter. Organic matter is something that was once living. That's what that term means. Organic means it was once living, comes from the earth. So generally the layer has the largest influence on crop production because plant roots are only going to grow in those first couple inches to first couple feet of the earth's surface. And so the organic matter is going to give, that good soil and nutrients to the plant roots that grow there. The B horizon. The B horizon is the subsoil. It is a subsurface layer. It is underneath the subsurface layer. That's what it means by subsurface. So the B horizon is mostly subsoil. It has an increase in clay content. Clay is going to be that stickier soil material that is responsible for holding much more water than sand or silt. So it generally has the greatest influence on urban uses such as building sites, because when you build a house or build a building, you get rid of that topsoil layer, the A horizon, and you go right to the clayish, harder subsurface area, and you put the foundation of that building on that. There's a C horizon. The C horizon is made up of parent material. This is bedrock. It releases water to the upper soil layers. And it contains larger soil particles, including gravel and larger rocks. It also may have a higher clay content and is usually harder soil to dig in. So this is an image of the soil profile. As you can see in the top part right here, you have the O horizon, the first couple inches where plant roots are going to grow. And then the A horizon, 6 inches right here, darker material. And then as you move to the lighter material, there's less organic matter in the B horizon. And then where the more clay content is, it's the subsurface. And then you go to the C horizon, you're going to see those larger rocks. It still has a higher clay, or other soil particles. And then the R horizon is going to be bedrock. This is really the area where a lot of water is held because it can't penetrate through this rock. So again, that soil profile, as we see right here, is going to change. It's not going to be the same in every single environment. What you see at your house may be different than you see at your neighbor's house. But ultimately, this is what we look for, and they're the different layers. So soil texture and structure. The texture refers to the size of particle. So sand is the largest soil particle. You go to the beach, you see the single sand grains. It's the largest soil particle. They have problems holding water. If you pour water on sand, it's going to run through quickly. Since they're large, there's larger gaps in between the particles. So it doesn't usually contribute to good plant growth, but they do drain well. Individual particles can be seen with the naked eye. Silt is the second largest soil particles. Is in between the largest and the smallest. It's intermediate in size. And it cannot be seen with the naked eye. You actually need a magnifying glass to see silt particles. Clay is the smallest soil particle. Really, a lot of people don't think about this, but clay, when you see it in clumps. It sticks together very well. It holds a lot of water. Because it is a small soil particle, it's actually, less water can fit between the places of clay, and therefore it holds water. Water will sit on top of it. Think of a clay bowl. Or anything you made out of clay. And so they're the small soil particle. They're microscopic in size. And like I said before, they hold a lot of soil, and they're usually infertile. They don't contribute to good plant growth, and they're associated with wet soils. All right, so here you see the sand. There you see a mixture of silt, and there you see a mixture of clay. Don't always let the colorations of the soil confuse you. A lot of times these soil can have other colorations depending on what nutrients are in them. So the structure of soil, it refers to the tendency of soil particles to cluster together and function as a soil unit. These soil units, or these clumps, are called aggregates. So aggregates refers to the soil clumps, and they leave pore space to store, and in between the soil particles, you're going to see air, water, nutrients, and they allow for root penetration. So single grain is a structure. Usually you're going to see this with sandy soils. There's granular. These particles cling together to form rounded aggregates. They're very desirable for all soils, good for plant growth. And there's blocky. Just picture Legos just thrown into a pile. That's usually what blocky looks like in a soil. Particles cling together in angular aggregates. They're typical of soils with high clay contents. So here you can see the different soil structures. You have the single grain pieces, not closely held together. The drainage through that, you can see the water is going to be very rapid. Water's going to run right through that pretty quickly. There's blocky. You can see that right here. Platy is another type. It's just plates of soil. It runs through slow because there's not a lot of space for water to go through. There's massive. Water's going to run slow through that because it's just a giant clump of soil. Then there's prismatic. These are column pieces of soil. Water's gonna run through that moderately. And then there's granular. You can see that right here. Larger than single grain, but still a small piece of soil held together. And water's gonna run through that rapid as well. Soil classification. One of the most important things that we talk about with soils is the land capability classes. So a land capability maps are based on the physical, chemical, and topographical aspects of land. So land capability classes are designated by Roman numerals 1 through 8. And so a land class of 1 is the best. So 1 and 2 land classes best land for most intensive cultivation of field crops with the fewest limitations, and they can be planted year after year. So these land classes of 1, they can handle the most intense crops like tobacco that requires you to till the land every year. They're very good soils. And then as you move into class 6, these are very steeply sloped. You think of more mountainous terrain, and they're best used for trees. Trees grow better. Actually, trees grow great in class 1, but you'd rather use your class 1 for these high cash crops like tobacco, and then use class 6 farmland or higher up for trees and things like that. So like your mountainous areas, in North Carolina, that grows a lot of the Christmas trees for the country. And then class 8 soil is best suited for wildlife and recreation. You're not going to get this very rocky terrain, mountain, like the slopes of mountains, cliffs, things like that. You're not going to get good, farming practices can't be used there. So this shows you land capability classes, what can be used there. Class 1 can be used for everything. Class 8 can't be used for anything but forestry and wildlife. So soil conservation, there's 2 types of erosion. There's sheet erosion and there's gully erosion. First off, erosion involves when the top layer of the soil disappears through wind, through water, however it just goes away. So sheet erosion, it removes layers of soil from the land. Gully erosion, it's the removal of soil that leaves trenches. And so on a sheet, you're just removing a whole top piece of soil, almost like pulling the blanket off your bed. Gully erosion is like if you take the water hose and stick it into the soil, it's going to create this trench or this ditch. There's no-till practices, and this is a cropping technique used to reduce soil erosion. So you plant something like soybeans, and as soon as you harvest the soybeans, all that's left is the sticks of the soybeans, and you go right back over top and plant wheat. And so that's a good cropping practice called no-till. And so crops are planted directly into the residue of the previous crop without plowing or tilling. When you disc and plow and you turn up that soil, you're disturbing that soil. It's an effective means of erosion control. It's a popular technique used especially throughout North Carolina and the country. And then there's conventional tillage. It uses tillage systems that disturbs the soil surface by plowing, disking, or harrowing. This essentially involves turning up the soil. And sometimes conventional tillage is necessary, or a lot of times it's necessary for crops like tobacco and corn. Conservation tillage is intermediate tillage system, conventional and no-till. So it's a combination of both systems. So that's all I got for you guys for soil. Next time in environmental science videos, we're going to talk about wildlife management.